Next section, X.3 floodplain encroachment. So floodway is the encroachment on the channel could be performed until the water surface elevation during 100-year flood would not be increased more than 1 feet. That is the definition of the encroachment of the floodway. And this figure shows the plan view of the floodplain for Rifle Colorado River. Okay, showing floodway 100 year and 500 year. In the dark gray is 100 year, and the light gray is 500 year. So 500 is a bit larger compared to 100 year. And how to get this? First, we have to identify the depth of each section, and location of the limit of the flooding can be established on the contour map of the area. Okay. The next example show how to identify the encroachment or the location of the limit of the flooding. This example, the channel shown in the below figure has a slope of the 0.001. So that is the S naught, and 100 year first. Peak is 100,000 cubic foot per second. Determine the minimum width of the channel that would meet the criteria in the definition of the floodway. Assume that overbank area is covered with the long glass and main channel is a straight gravel bed river. So it means that median is the difference between the overbank area and the main channel. And further assume that the encroachment occur over a long enough distance so that the flow occur at the normal depth throughout the part of the channel that is of interest. So this is a cross-section area. We divided the whole area into the area B, area A, area B, and area C. Okay, and the depth of, we don't know the depth of the flow, but we know that manning end. Okay, for the overbank flow is 0.003, and on the main channel is 0.025. Okay, and given this dimension, we can estimate the area of the flow is a function of the y. Okay, so y we don't know the depth yet. Okay, for the area A, this is function for area A, and with the parameter for area A, and it's for area B, and with the parameter for area B. You can do by yourself for area C. Okay, so next we have going to determine the normal depth both before and after encroachment. Okay, we start to write equation of Q is a function of the velocity and area in each sub-area. Next, substitute the equation of Manning equation, and for the slope, we assume the slope is the same for 3 parts. And next, we substitute parameter in the equation of Q. Since areas A and AC is equal, so we can assume that the area and radius part A and part C are the same. We can combine the equation to get equation Q is this number. And for the head radius for part A and head radius for for area B. Okay. The next step, we have to assume Y to solve Q, RA and RB. In the next table, we start to assume Y is 20, so we can estimate the area A 0, radius A 0, so we get the Q is about 55,000. And next, we increase the depth to 20, so we get increase the Q. It could be like 67,000, and next we try to increase to 24, increase to 82,000, and 26 and 26.2 is closer. Sorry. Okay, it's a bit higher compared to the Q is 10,000, so we reduce to 26.1 is very closest to the flow 100,000. So we assume that normal depth is 26.1. Next, we have to, after encroachment, the depth increase to from 26.1 to 27.1. So we write equation of the area vector parameter of area B, and vector parameter for area B is a function of the B. Okay, B is the, in this case B is encroachment width. Okay, encroachment width. After we got the area and vector parameter is a function of B, the next we can solve that is the radius for area B, sub area A and sub area B. Okay, and we make a trial and Euler solution. Assume that for the encroachment width, okay, we assume that for start from 240, so we get the Q, okay, from this equation. And once we increase the B, we increase the Q until we get 365 is come closer to 100,000. So we can find a solution that the width of the floodway is 565 and the depth, normal depth is 27.1 feet.